Okay, slope-intercept form. So I've kind of been lying to you a little bit. Not really lying to you, but if I were given an equation like this, y equals 1/2 x minus 3, I would not graph it with a t-chart. I wouldn't. You could. It's totally a good way to do it. But this form of the line is called slope-intercept form. Slope-intercept form in general is written as y equals mx plus b, where m and b are numbers. So in this example, m is 1/2 and b is -3. But it turns out there are a lot of patterns when you write an equation in slope-intercept form. Slope-intercept form is sometimes called y equals form, kind of not by, you shouldn't call it that. You should learn that it's called slope-intercept form, but some people call it y equals form because it helps us remember that y equals is the beginning of slope-intercept form. And that's really how we know that something is in slope-intercept form. If it says y equals, that is slope-intercept form if it's a line. And how do we know it's a line? Remember, lines have y and x, but they never have x squared or x to the third or anything like that. And they never have 1 over x or 1 over y or anything like that. So it's a line as long as our x and or our y don't have a power and aren't in the denominator. So slope-intercept form, y equals, and it's a line. Those are kind of the two requirements. And m and b have meanings. M is actually the slope of the line. And b is what's called the y-intercept. So we've talked about slope. Slope is the steepness of the line. The y-intercept is simply the place where the line hits the y-axis. So if I have an x-axis and a y-axis, the y-intercept is the place where my line crosses the y-axis. So here's the y-intercept of that line. Here's the y-intercept of this line. Here's the y-intercept of this line.
Wait, on the second line,
This over here, what do you think this would be called? Giving you a hint. These are called the x-intercepts, right? Because that's where they cross the x-axis. But the y-intercept is where it crosses the y-axis, which is that vertical line. Okay. So because we know the slope and y-intercept, that's actually all you need to know to graph a line. I'm going to show you how. You're going to be able to graph these in less than 10 seconds. Okay? Y equals 1/2 x minus 3. So what do I know? I know that my y-intercept is -3, and I know that my slope is 1/2 or 1 over 2. So here's how I would graph that.
I thought it was 3.
Yeah, so the trick is I do have to include the negative of the 3. I'm going to start with the y-intercept. My y-intercept is -3. Okay, 1, 2, 3. There's the first point. My slope is 1 over 2. Remember, the slope is the steepness? So I'm just going to do my rise and run from this point. And this is the thing that's a little weird about this. We start from this point. Instead of starting from here and counting, we're going to start from right here and count. And I'm going to count up 1 over 2. But then guess what? The slope never changes. So the slope is also up 1 over 2 from this point. So I can go up 1 over 2. I could even do it again. Up 1 over 2. In fact, not only can I go up 1 and over 2, up 1 and over 2, up 1 and over 2, I actually can imagine doing that backwards. How would I get to this point?
Down.
Yeah, in a way it's like down 1, back 2, right? Or down 1, back 2. As long as I'm going up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2 each time, I can just make as many points as I want to along that line. How many points do I need to make a line?
3.
We made 3 to check, but really we need 2, right? 3, I usually would make more than 2, just for the same reason we made 3 with a T-chart. It's just to make sure I'm getting the straightest line that I can. I would actually, with this, I would just make as many as you can fit on your graph, going forward and backwards. Okay? Or you could make like 2 or 3 and then use a ruler to try to make the line really straight. But it's not hard. And once you start practicing this, you'll see that you can actually make these points pretty quickly. So let me do another example. Y equals negative 2/3 x plus 5. Okay, where am I going to start? To graph this, I start at the y-intercept. My y-intercept here is positive 5. So that means I go up 1, 2, 3, 4, 5 and make a point. My y-intercept is positive 5. Then I use my slope to find the next point. Since the slope is negative, it doesn't matter if the negative is right there or right here. Right? Negative 2/3 is the same as negative 2 over 3. Same number. Right? That means that instead of going up 2 over 3, I'm going to go down 2 over 3. So starting from my y-intercept, I go down 2 over 3. Down 2 over 3. And that's about all that's going to fit going that way. But I could also reverse it, right? Kind of go up 2, back 3. And I would just check. Is that the same thing as going down 2 over 3? Yes. They all line up, and I'm done. That is my line. That is my line. You see how fast this is going to be? Right? So let's do another example. What if I had y equals 3/5 x plus 1? Where do I start?
1.
Yeah, I'm going to start with a y-intercept, which is 1. So 1 right here, positive 1. And then I look at my slope. The slope is 3 over 5. So I go up 3 over 5. I'm not really going to be able to fit another point on here, but I could go down 3 and back 5. And I would see that I have a straightish line going through those points. So between any 2 points, I'm going up 3, 1, 2, 3. Oh, oops, sorry. 1, 2, 3 over 5. 1, 2, 3, 4, 5. Up 3, 1, 2, 3 over 5. 1, 2, 3, 4, 5. And on graph paper, this gets a little bit easier even than it is on the board. Because we don't have to make the axis. We don't have to try to find the points. We can just count. Yeah.
When you go up 1,
So I started at 1
yeah.
right there. Because that's my y-intercept, right? So that first point, the first point that I put on the graph is just the y-intercept. And then the second point I find by using the slope. Up 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Now, this is not magic, right? It's not like this comes from nowhere. If we had made a T-chart of this, we actually would have done the exact same thing. We would have probably started with x being 0 and y being 1. That's that point right there. And then we probably would have picked 5 for our x, and we would have found that y would be 4. That's this point right here. 1, 2, 3, 4, 5. 1, 2, 3, 4. It's just that instead of making the T-chart and finding each point individually, we're using the y-intercept and the slope to find one point from the next point, which is a lot faster. And it's just using the basic essence of math, which is patterns. Right? We're finding patterns. If this is the y-intercept and this is the slope, then here's my y-intercept, and I go up 3 over 5. That's a pattern. And it's a pattern that's going to apply to all of these lines in slope-intercept. So we start with the y-intercept, and then we use the slope to find our next points. But what if the equations don't look exactly like this? Right? So the simplest example I could give you of something that might confuse you at first would be just something like this. Let's do minus 2. So I think it's pretty clear where to start from. Would you agree with me that I'm going to start with a y-intercept of -2? Which is where on the graph?
Down.
Down. How many?
2.
Down 2, right? So my y-intercept is 2. But now here's the issue. My slope looks a little different. The slope is 3. The slope is 3,
It could be 0.
and it's not a fraction.
3. No, you put a 1 down under.
It is a fraction. 3 is a fraction.
Woo!
It's 3 over 1. So how am I going to find my next point? I'm going to go up 3, 1, 2, 3, over 1. 1. Up 3, 1, 2, 3, over 1. Or I could go down 3, backward. And I'm going to see that this gives me a pretty steep line.
Oh no, it's steep. I can't walk up that.
Right? A steep positive slope. What if I had something like this? Y equals negative 4x plus 5. Here are my axes. Where do I start? What is my y-intercept? 5. So I go up 5, 1, 2, 3, 4, 5. Always start with that y-intercept. And then what is my slope? Negative 4 over 1. Remember, every number is a fraction. So I could go down 4, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. Right? And I've got this beautiful, perfectly straight.
Wait, can you find other things down on the other side too? And then
I could keep going this way, right?
Wait, can we make a mountain with another problem and put snow on the top?
Could we write an equation of a line that went right through here?
Yeah.
We
And then
totally
we put
could.
stones and stuff.
You could totally do that.
Can we start the whole one?
Not yet. There's a couple more things we need to go over with it. What if Gary just made a surprise appearance in the video? All right. Y equals 1/2 x. Wait a second. What's different about that? Is that slope-intercept form?
No. Or I guess. We could use 1 or 0.
What's missing?
No, we can.
Slope-intercept form is y equals mx plus b. What's missing here?
We're missing the y intercept.
We're missing the y-intercept.
So we put 0.
Totally. Right? Wouldn't you agree that 1/2 x is the same as 1/2 x plus 0?
Oh.
That's the same thing, right? If I add 0, I'm not changing the numbers. 5 and 5 plus 0 are the same thing. 17 and 17 plus 0 are the same thing. So even though it looks like there's no y-intercept there actually is. What is my y-intercept?
0.
Where's that?
In the middle.
Right there. It's saying that my y-intercept is at 0, 0. And then I'm going to go up 1 over 2. Up 1 over 2. And I've got this gradual line going right through the origin. The origin is the name that we give to that point 0, 0 right at the middle. Okay? What about this? Y equals 3x. What is my y-intercept on this one? That's my slope. So my slope I could think of as 3 over 1. What's my y-intercept?
Plus negative 0.
Plus 0. So my intercept is right here. And then I'm going to go up 3 over 1. Right? Up 3, 1, 2, 3 over 1. And I've got a pretty steep line going through the origin. So even though it might have looked at first like there was no y-intercept and there was no bottom to the fraction, it actually is.
It's just invisible.
So sometimes we have to remember, right, that mathematicians love shortcuts. They're not going to write 3 over 1x. They're going to write 3x. But technically, the slope is 3 over 1. The rise is 3 and the run is 1. It's the same thing. Now, what about this? Y equals x plus 2. What seems to be missing here?
The slope.
What do you think the slope is of this line?
Maybe 1. So, but x is 1. So
1.
1.
Right? Because x is the same thing as 1x. But even that is not really the slope we're used to. We're used to a slope having a numerator and a denominator.
And then you put 1 under it.
So we could even imagine it as 1 over 1. Now, I want to just say something really quick. In your notes, how are you going to show yourself that what we started with was y equals x plus 2, and we turned it into this, right? Yeah, you might want to circle this. You might want to make a note to yourself, right? If there is no number in front of x, it's 1, right? If there is no denominator, it's 1. If there is no y-intercept, it's 0. Because we have to add 0, but we have to multiply times 1.
Or you can just write it down.
So how would we graph y equals 1 over 1x plus 2?
Well, we go 1.
What's our intercept?
So, 2.
2, so I'm right here.
So then we go up 1 over.
Up 1 over 1. 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 Right? I could even go down 1, back 1. Down 1, back 1. Right? I'm going to end up with all these points perfectly sort of along my line.
Give it snow. Next to my skiing gown.
Perfectly along my line. Okay. Interesting. So what if I just had this? How would you graph this? Y equals negative x. Right, it's a negative 1, good, over 1, plus, what's my y-intercept? 0. So y equals negative x turns into y equals negative 1 over 1x plus 0. No mathematician in the world would ever want to write all this extra stuff, right? Because we're lazy. All of us mathematicians, we want to write things in the simplest form that we can. But sometimes adding these extra things helps us remember the pattern. So where do I start? Start from 0. Beautiful. Down 1 over 1. Down 1 over 1. Right? And I'm going to have sort of this perfect 45-degree line. Right? That makes sense? Okay. One last thing with these. Actually, not, well, sort of. What if I had this? Y equals 5.
It would be over 1 plus 0.
What's actually missing here? The x. So
over 1
ooh, I heard something really interesting. I heard y equals 0 plus 5.
No,
Yeah, what is 0 here?
5. Yeah.
What is 0 here?
X.
Yeah, 0x. So my slope is 0, right?
Yeah.
Right.
Oh.
My slope is 0. Because what is y equals 5 as a line?
It just be straight.
It just be, yeah. All the lines are straight, but this one is horizontal, right? So y equals 5, and the slope is 0. So I go up 0 over 1.
Over 1.
Y always equals 5. It's a horizontal line. But it does go through 5 as a y-intercept. That is telling me the y-intercept right there. Now there's one type of line which you've seen before, and you may see again, that is not in slope-intercept form. And that would be if we had this. X equals 3. There is no way to put this into slope-intercept form. It's not y equals. There is no y.
It's undefined.
The slope is undefined. And that's why we can't put it in slope-intercept form. Because slope-intercept form requires us to have a slope. But this line doesn't have a slope. It's undefined. So let's just quickly remember, how do we graph x equals 3? X equals 3, so we find where x is 3, and we just make a vertical line. Right? No matter what y is, x is always 3. So this point here is 3, 0. This point right here is 3, 2. This point right here is 3, 5. This point right here, 3, negative 1. All of these points, x is 3. But y doesn't have to be anything. It can change, right? The slope is undefined. So if I were to say I was going up, like from here to here, I have to go up 2 over 0. But 2 over 0, friends don't let friends divide by 0. Right? So 2 over 0 is undefined. We cannot do that. Imagine this. Imagine if I gave you the job of splitting 2 pizzas equally among 0 people. How could you do that?
No way.
You can't. If you have 0 people, how many pieces of pizza does each person get?
0. No.
Well,
You're
but you still have 2
you can
pizzas.
eat those 2 pizzas.
Okay, so we could change the problem and we could say, well, I'm there, so there's 1 person. But then I'm splitting it amongst 1 person. You can't split things over 0 people. It's not possible, right? You can't put 2 into 0 groups. Another way to think about division rather than sharing things is to think of it as grouping things. You can't put 2 into a group of 0 because you have 2. No matter what, you have 2. So how many groups of 0 or how many 2's would there be in each group if there are 0 groups? It doesn't make any sense. And so when we have something over 0, we're not going over at all. That is an undefined slope. And we can't write these equations in slope-intercept or y equals form. It's not possible. But we can still graph them. They can still be graphed. Just not as slope-intercept equation. All right. Beautiful.